Welcome to this webinar about highways runoff. This is a webinar hosted by the CIWEM policy team and Stormwater Shepherds. I'm going to just move on to the next slide. Hopefully you can see that, just for a few general housekeeping tips. So the webinar is being recorded. If you experience any technical issues and need assistance, please use the chat feature on Zoom. So not the Q&A feature, the chat feature. We'll take questions at the end of the presentations. If you've got questions as we go through, please use the Q&A button. And just a note on CPD at the bottom, so you can put 1 hour of CPD to this webinar. Okay, so I'm chairing today, and my name is Kat Moncrief. I'm from CIWEM. I'm Policy and Engagement Manager. And just a little bit about CIWEM and Stormwater Shepherds before we kick off. So CIWEM is a Royal Chartered professional body and independent charity. Stormwater Shepherds is an international not-for-profit that's committed to restoring health to all our waterways. And the vision for Stormwater Shepherds is for the world's waters to be clean water, free of plastic and also urban pollution. So today we're talking about our highway report, which we've launched today. So it's hot off the press. The report is shining a light on road pollution, and it's a partnership. The report's come out of a partnership between Stormwater Shepherds and CIWEM. There have been a number of reviewers and contributors, but today we're hearing from two main speakers. So we've got Joe Bradley, who's Stormwater Shepherds UK, and also Leanne Lundy, who's Professor of Environmental Sciences at Middlesex University. So Joe has been involved in the report. She's one of the lead authors, or is the lead author, I should say, and she braved many a rainstorm and busy roads to collect the samples which we unveil in the report. Joe has a passion for preventing and controlling pollution, and she was at the Environment Agency for many years, and she was in fact the lead author on some of the Environment Agency's pollution prevention guidelines. And she also worked on a joint Environment Agency and Highways Agency initiative to prioritise highway outfalls on the strategic road network. So she knows a huge amount about the issues that we're going to discuss today. And then Leanne was one of the many report reviewers and contributors. As I said, she's a Professor of Environmental Science at Middlesex University. She has been very focused on stormwater, and she's got a huge amount of experience researching the sources, behaviour and fate of stormwater. And she's also more recently done a lot of work looking at an ecosystem approach, so sustainable urban drainage system type approach to managing urban runoff. And I should also say that the report was very kindly funded by Reece Jeffries Road Fund. So that's a fund which encourages and promotes better and safer roads. So I think that's probably enough from me. I'm going to hand over to Leanne, who's going to take us through her slides, and she's going to focus on the kinds of pollutions that we have in highway runoff and what happens to those contaminants and how they affect the freshwater environment. Okay, Leanne, I'll hand over to you.
Leanne, you're on mute, buddy.
Very professional. Okay, let me just share my slides. Okay, let me just. Yeah, can you see them in slide view?
Yep.
Okay, hello everybody. It's an absolute pleasure to be here. My brief is to give you a brief overview of highway runoff research with the focus on pollutants, impacts and treatment. I was asked to start with a historical take. So to be systematic, I put the terms road runoff, highway runoff, motorway runoff into the research database Scopus. And that pulled out over 1,000 articles, around 1,100 articles. So if we look at this little diagram here, there's the timeline along the bottom. So you can see the road runoff research sort of began in the late 1970s. The first paper was in 1977. And on this axis, we've got the number of articles published per year. So each bar is a year. So you can see sort of 4 to 5 research papers a year, sort of the 70s and 80s, a gradual increase. But from 2008 onwards, we're sort of getting to 40 to 50 papers a year. And the most papers we had was in 2022, and that was 63 articles. So when we talk about the weight of evidence, this is the sort of the research base that we're drawing on. So these are all peer-reviewed publications. So if we look at the topic of these papers, these early papers in the 1970s, the initial focus was on metals and on chlorides, so chlorides from de-icing salts. And as we move into the 1980s, we started to see research on organics with a particular focus on polyaromatic hydrocarbons. Sort of a highlight of the 1990s was the Highways Agency and the Environment Agency's 5-year study on highway runoff. So that was looking at monitoring quality and looking at treatment as well, using a variety of SUDS systems. So this was a major study, collected samples from 6 different sites. That was actually published in 2006, so that's when it appeared in the peer review literature. Moving on to the late 2010s was the explosion of interest in microplastics, and the first paper on stormwater and microplastics was published around 2019. We then moved into tire wear particles. So tire wear particles tends to be included within microplastics. They're both different types of polymers. Tire wear particle analysis it's really challenging. There are methods available now, but to start with, the first papers were predictions looking at the emission of tire particles based on emission factors. So that came out sort of around 2020, and improvements in analytical techniques when we started to see field sample data on tire wear particles in around 2021. There's still a lot of interest in stormwater and microplastics, but currently the hot topic now is PFAS, the forever chemicals, and we've just seen a paper published on PFAS in tunnel wash water. So the key information here is that is a common theme really. So irrespective of the pollutant type, and that changes over time, that stormwater runoff is continually seen as it's a pathway to move pollutants from the land to the receiving water. So if that's our evidence base, what can we say? What do we know about sources from the literature? So this figure gives an overview of the principal stormwater pollutant sources and types. So you can keep kind of a central component is highway surfaces, and you can see highway surfaces obviously get input from traffic and traffic infrastructure and road wear, but they're also in receipt of pollutants from a variety of other land uses. So for example, construction sites, what happens on the green verges and green spaces, atmospheric deposition can all end up on roads, on highways, which then kind of act as a pathway, moving flow via gully pots into surface water sewers, and from there into receiving waters and potential for interaction with groundwater. So the key point on this slide is there's a diversity of sources that contribute different pollutants in different concentrations. So it's starting to get an idea about why it can be so complicated to predict what road runoff concentrations are going to be, because there's so many sources, and then once it gets into the pipe system, different processes can occur. So if we know about the sources, what do we know about the concentrations of these different pollutants? So this table pulls together information from a variety of different studies. So what you can see here for different key pollutant types, we have an idea of the concentrations that are associated with different types of urban land uses. If we look at the event mean concentrations, so that is event mean concentrations, average concentration for the whole of the event. So what we can see here is we're getting a range in concentrations, and that can span several orders of magnitude. And the reasons for that, are this is from a variety of studies, so different contributing areas, different rainfall events with different intensities and frequencies and duration, differences in antecedent dry periods, so how long the pollutants have had to build up on the surface area before being discharged. And another key point, which I'll keep making, is the lack of a standardized sampling methodology. So samples are collected in different ways, and that can make it really hard to compare the data between different studies. So a key point here is that a range of different land uses are contributing pollutants in different amounts, but we tend to get the highest concentrations associated with the busiest roads. So if we move on to, we know that I have an idea of the concentrations that we can anticipate in runoff, in highway runoff. So the next question is, are these concentrations that can cause harm? So in this table, we've got data from the literature, which is in comparison to guideline values. So this data comes from a study by Mitchell, 2001, and we have the mean concentrations for a range of common urban pollutants and a range. And then we want to compare them to water quality standards or guideline values. And this is another place where stormwater research starts to get a bit tricky. So one of the challenges we have is that we have no stormwater environmental quality standards. So there's no water quality standards for stormwater runoff. The kind of the go-to place for water quality standards is the Water Framework Directive, and this is for receiving waters. And so therefore, if you want to compare runoff data to receiving water, you need to allow for dilution. So that's one challenge. Another challenge is that not all the pollutants that we're interested in have a receiving water standard. So for example, total suspended solids and pyrene, there is currently no EQS for those pollutants. So there needs to be some kind of conversion and adaptation going on if you want to make that comparison, if concentrations are there at a level that can cause harm. So within this study, and there's various kind of superscripts here talking about the different processes that we took to convert, so we could do a comparison, and I can talk about that later, or I can refer to the publication. But the key point here is that the mean concentrations of all these substances exceed the converted water quality standard that we use for the comparison. So moving on rapidly to ecological impacts, what kind of impacts have been reported in the data, in the literature? Well, the focus has been on acute tests, and this particularly looking at the impacts of metals and PAHs. So if we're talking about tests, and this has been in the field and in the laboratory. So the kind of tests that have been used have looked at changes in community composition and abundance, species level, community composition and abundance at a species level. It's looked at behavior change, changes in growth, reproduction, gene expression, up to mortality. So a range of different endpoints, and we've looked at a range of the studies on a range of different trophic levels, so vertebrates, invertebrates and producers. And within each of these trophic levels, there's been a variety of species. So for example, if we talk about fish, and it's not only many species of fish, but within a species of fish, you might see studies on fish eggs or juvenile fish or adult fish or part of the fish liver, for example, depending on the type of pollutant. And different species, different life stages can show different levels of sensitivity. So that's another reason why it can be a bit complicated in terms of comparing studies, because again, there's no standard methods. So while we have studies that show an effect, we do also have studies where we don't see an effect. So for example, in this example given here, so studies where receiving water ecology downstream of a highway discharge site does not significantly differ from those upstream. And we think we're sort of understanding the factors, a range of factors for this has been suggested. So, for example, receiving water characteristics, so water hardness is a really important issue. Perhaps in field studies, populations that are in the field at the upstream site, for example, may already be acclimated to pollution from a source further upstream. We know that runoff can be called the pollution cocktail. There's many different substances, and we don't fully understand the sort of the antagonistic and synergistic effects of those. We also think that climate and geology, the background geology, has an impact. So we're starting to understand the factors that make this challenging, but we don't fully understand the interplay of these factors. So whilst it's hard to establish this causal relationship between chemical and ecological status, using a weight of evidence approach, we can conclude that highway runoff can negatively impact the chemical and ecological status of receiving waters. So if we move on to treatment, treatment of road runoff using SUTs. So there's international recognition that urban runoff requires treatment. And I guess some of you will be following the revised Urban Wastewater Treatment Directive text, which has just been adopted. And this has the need to tackle urban runoff at sites where it poses a risk to the environment or public health as one of its key elements. And the text requires member states, unfortunately not the UK, but it requires member states to undertake monitoring to characterise the problem from runoff and put in place measures to mitigate runoff. So best practice for treating runoff is sustainable urban drainage systems. And so whether that's the large storage systems like this pond here, infiltration basins, infiltration trenches, roadside swales, filter strips. The key point in this slide is there's data in the literature on the performance of a wide range of systems that come in different shapes and different sizes and can be installed in different scenarios. If we look at sort of treatment performance data, so there's studies in the literature showing the removal of a wide range of pollutants. So removal from the water column, typically to the sediment where it's then degraded, or it remains in the sediment until it's disturbed. And we see sustained performance over time. So some of the systems that are being monitored are upwards of 30 years old. Sediment concentrations are typically low concern levels in the literature. But again, there's not specific standards for stormwater sediment. So when they say concern levels, they mean perhaps comparison with contaminated land guidelines or hazardous waste. Operation and management guidelines. There's operation and management guidelines coming out over our years. There's many for all different types of systems. These are available. But I think where information is limited is we have the breadth, we have studies for many different types of parameters, but we have less than 5 independent studies for most pollutants, for most SUDs. So we have breadth, but we have limited depth. And again, different sampling methodologies makes it hard to compare between different studies. So after a very rapid roll through 45 years of research, in conclusion, within the literature, we can see elevated concentrations of many pollutants are reported at concentrations that exceed these converted receiving water EQS. So that's allowing for dilution, and you have to make some assumptions around that, changes in speciation, etc. Several detailed studies have reported impacts in receiving water ecologies. So these studies, as I mentioned, are over different trophic groups, different species, different life stages, which is a strength in terms of understanding the breadth of impacts. But again, it makes it hard without these standard methodologies. It makes it hard to do this kind of meta-analysis that would be really useful. We do also have studies where no ecological impact is reported. And while we understand or can identify some of the factors that contribute to this, we don't fully understand the interplay of these factors. There's a strong evidence base that using SUDS can reduce pollutant loads discharging from highways to receiving waters. And there are tools available to support users identify where and how highway runoff can be treated using SUDS. And here I am just going to flag a tool that's been developed the methodology underpinning the tool was developed by myself and colleagues at Middlesex University, and it's been integrated into an online open access tool that's hosted by Thames 21 and BGS. So that's it from me. Thank you. Sorry it was so quick.
Thanks, Leanne.
Thank you. And now I'll pass on to Joe, who, as I said, was the lead author of the report. And Joe was out collecting samples in the northwest of England, which we show in the report. But I'll let Joe talk you through that and the report's findings. Over to you, Joe.
Thanks, Kat. Yeah, hello. So just a quick intro. Stormwater Shepherds is a charity dedicated to reducing urban pollution. So that's what we try and do. And most of you who know me will know that I've been focused on pollution from highway runoff for about a decade, I suppose. So part of the reason we wrote the report and we wanted to promote the report and share it as far and wide as we could is that there's a lack of, we have got a poor balance at the moment in the UK of focus on pollution. So there's a massive social media focus and press focus on pollution from sewage overflows, partly because of very vocal activists achieving great things with their social media. There is some talk now about agricultural pollution, particularly on catchments like the Wye, but urban pollution and pollution from urban surfaces has taken a back seat all the time as these narratives have unfolded. And we need to change that, because actually as a source of pollution, it is one of the three main sources of pollution in British rivers. And so the Water Framework Directive data does highlight that, and it shows it as causing failures to comply with the Water Framework Directive in about 18% of water bodies. But I think that's an underestimate, because the individual outfalls that we know of, like the one in the photograph, are causing pollution. And there are National Highways operates 25,000 outfalls, and we think there are 1 million outfalls or so across all highway operators. They're not identified explicitly in the river basin plans. So there are some river basin plans on some water bodies that are being affected by pollution from highway runoff, and it's not identified in the reasons for not achieving good. And I think because of that, 18% is an underestimate. And actually, if we talk about the balance of pollution sources, I would put highway runoff, I would say that, wouldn't I? But I would put highway runoff up alongside sewage. One of the other reasons why it doesn't get the attention it deserves is because it's not monitored. Nobody measures this pollution. The Environment Agency don't have any monitoring points that are specifically located to catch this pollution and measure it. They don't routinely measure for polyaromatic hydrocarbons in most water bodies. And indeed, up until a few years ago, they didn't do very much polyaromatic hydrocarbon analysis at all. And also many of the WFD monitoring points are a long way downstream. So I'll talk a little later about a little stream in Chorley called Sidbrook, which I visited back in the last year. And Sidbrook discharges runs through a little village called Eccleston. But the motorway discharge is about 3 miles upstream of the monitoring point. And in that 3 miles, there's a pool and a culvert and a lake. So it isn't detecting the level of pollution that outfall is causing, because the monitoring point is in the wrong place, perhaps. And the other thing that's really important, and I labour this point a lot, is you can only measure this pollution if you go out in the rain. And I don't know what proportion of Environment Agency routine sampling is done in the rain. A proportion of it will be, but I don't know what the proportion is. And if it isn't raining, then you don't catch this pollution. The other thing, and I've only one slide on groundwater protection, and I apologise for that, but it is incredibly important, but we have very little information. So this photograph is a roadside ditch by the side of the A3M. and the runoff from the A3M goes straight into that ditch. And I don't know if you can tell from that image, but that's on the chalk. And there's literally chalk. The surface is part of the chalk geology. There are rubber berms, rubber covered berms in the ditch to encourage the water to stay behind and then infiltrate to ground. And we have no idea of the harm or not that is causing to the underlying groundwater. And because there is no measurement specifically targeted at measuring that problem. And so we have no knowledge of that, the extent of that problem. This is just to give you an indication of this monitoring problem. This is the little red arrow is where Massey Brook goes under the M6 in Cheshire. And I'll show you later a sample from the discharge into Massey Brook. Massey Brook then discharges down to the north, going up that image into the Bridgewater Canal. And there are two little blue dots there, they're septic tanks. So they are permitted discharges that the Environment Agency has the power to sample if they want to, but there are no sampling points on Massey Brook. So the pollution caused, or at least not in the extent of this image, the pollution caused by that discharge where that little red arrow isn't measured. And so we've got this problem with a lack of measuring and therefore a lack of data. And then we're building things like the source apportionment models without data to make sure that that's robust. And so I would argue that the source apportionment model for polyaromatic hydrocarbons underestimates the harm from highways because the data wasn't there. That is the discharge from Massey Brook, from the M6. It's just it's unusual because it is just a plastic perforated pipe, which is odd. But that was the day I took the sample, and you'll see the results later. It is diluted. The brook is bigger than the flow from the pipe, but the extent of that pollution I didn't measure on the day. It's difficult to measure. And as Leanne said before, we have standards, but the standards are for the watercourse downstream of the mixing zone. The standards don't apply to that outfall explicitly. So what we have to do is take the sample of the outfall and then try and work out how much dilution that outfall needs in order to achieve compliance with the standard. So Leanne's talked about this a little bit. Excuse me. Pollutants of concern in highway runoff. Always toxic metals. They've been knocking around for ages, and we've been talking about those for ages, particularly copper and zinc. Polyaromatic hydrocarbons, which keep me awake at night, and you'll understand a little bit more in the next couple of slides. And then microplastic tire wear particles. Now I don't talk any more about microplastic tire wear particles, particularly because they're fairly new. The research has been, as you saw from Leanne's graph, is fairly recent. There are millions of pounds worth of research going on as we speak into the conveyance of microplastic tire wear particles, the harm caused by them, the treatment of them, how to catch them. There's masses of research going on, but we know that they're harmful. We know that they cause harm to marine organisms. There's evidence that they find them in people's arteries when they do heart bypass surgery. I mean, these things are horrific, but we don't know enough yet, and I'm not going to talk about them a great deal. I'm going to focus on polyaromatic hydrocarbons. The really important thing about this topic is that word harm. What we need to understand is how much harm these discharges are causing to the water environment, to the creatures that live in the river, and how does that compare to the harm caused by other sources of pollution. We've got to get better at directing our investment at pollution that causes harm. So that's why this understanding of what's going on is really important. What I find difficult to get my head around, and I suppose this is probably really what keeps me awake at night, is this information. And I'm not a chemist, and I'm frankly not a scientist, so I read lots of papers and glean from them what I can understand. But polyaromatic hydrocarbons and toxic metals in the water environment cause all sorts of horrible things to happen to the creatures in there. So they cause them to, they have deformities, mutations, they have deformities at the embryonic stage. So by the time they hatch, they're deformed already, so they can't thrive and grow and survive. It interferes with their reproductive success. It interferes with the hatching of eggs. It causes abortions. It's the harm that it causes is nasty and insidious, and we don't really see it. They can cause death, and we do see death, but those sublethal effects are really, really important, and we're simply not measuring them. And that's what I want to try and unpick a little bit with our next set of research is what does that harm look like, and how does that harm compare to harm from other pollutants? The other thing to think about, and my Twitter feed is full of biodiversity collapse, and this is on a sort of slightly broader picture, it's quite important. Many of the insects that we talk about when we're talking about biodiversity collapse, they go through their larval stage in rivers. So when we do river insect counts, we're looking at mayfly nymphs and stonefly nymphs and caddisfly larvae and all these dragonfly, if we're lucky, all these creatures that go through a stage in the river habitat. Now, if we are poisoning that river habitat and causing harm and failure to survive for those insects, then we're also affecting the whole ecosystem. We're affecting the river ecosystem anyway, because we're causing harm to algae and invertebrates and microscopic organisms. But then if we reduce the population of insects that hatch out from the rivers, we're then having a knock-on effect on the broader ecosystem. So this topic, although it's something it's a bit niche and I get criticized sometimes for being so zoomed in on this topic, it is really important for broader environmental protection. So how are these pollutants are harmful? We know they cause harm. We're not necessarily certain how much harm, but we know they cause harm. So how are they regulated? You would imagine, wouldn't you, that harmful discharge like that is regulated. And because these discharges contain levels of priority hazardous substances in excess of the EQS, the environmental regulator should then come in and say, okay, is that enough to cause failures of the EQS in the downstream watercourse, downstream in the mixing zone? That's a role and a task that the environmental regulator takes on. Now, historically, everybody said, oh, well, it's all right, it's highway runoff, it's exempt. But it's not strictly exempt. There is an exemption in the environmental permitting regulations for discharges of highway runoff by a highway operator. But the exemption only exempts them from the need for an environmental permit if the discharge isn't causing pollution. And perhaps historically we thought it wasn't. We used to talk about something called clean uncontaminated surface water, and I suspect that we thought that road runoff fell into that category. Therefore, it was convenient to have the exemption, and we didn't permit them. Now we know that these discharges contain priority hazardous substances that the environmental regulator has a statutory duty to control. Then I would argue that task of assessing the risk and assessing whether or not their discharge causes failure downstream in the mixing zone is one that the environmental regulator should take on. At the moment, it doesn't happen. It doesn't happen at all. These highway outfalls are not assessed by the environmental regulator in England and Wales, and they're not permitted. They're not issued with a permit. And I think that's a problem. National highways have 18,000 outfalls off the strategic road network into the water environment, and they estimate that 1,054 of those are posing a high risk or a very high risk of pollution to the water environment. But they think when they validate their risk assessment process, 254 of them will fall into the category of high risk and very high risk, and will therefore be worthy of an installation of a treatment system. So just think about that for a minute. There's 18,000 outfalls, similar to those I've shown you in the photographs. And National Highways plan to mitigate pollution from 254 of them. And I just think that we're missing something. I think that that's not enough. And I would like to see this part of the environmental legislation applied. But that doesn't happen. National Highways and the Environment Agency have a voluntary agreement that says that National Highways operate their risk assessment. The risk assessment tool was built together by National Highways and the Environment Agency based on all that research that Leanne mentioned to you before. And so that voluntary agreement exists and those permits don't happen. But bear in mind that National Highways are not the only player in the game. So there are, we think, like, as I say, 25,000 outfalls and soakaways belonging to National Highways, roughly. We think there are probably 1 million outfalls across the UK from all highway authorities. So all your local highway authorities who manage all the other roads, they have also many, many outfalls that they don't know about. They don't know where they are. And equally, the water companies have lots of these outfalls too. So the photo there shows a discharge into the River Ribble. Beautiful piece of engineering that was built at the same time as the bridge. That drains the road that you can see in the background, and the gully pots drain into a central surface water sewer, which belongs to the water company and then discharges into the river through that pipe. And the discharge through that pipe has been sampled and has polyaromatic hydrocarbons in excess of the environmental quality standard. Now, it's worth pointing out the River Ribble there is huge and tidal. So it's likely that there is adequate dilution, that the river doesn't, or at least that one outfall doesn't contribute to or doesn't cause an EQS failure in the river. We have this difference in sort of processes, if you like, where you've got the voluntary agreement for National Highways and the Environment Agency, and lots of knowledge. National Highways have lots of knowledge about where their outfalls are, what catchment area they drain, what the traffic densities are, and then the local authorities and the water companies, who frankly don't know where their outfalls are, or a lot of them don't know where their outfalls are, and they don't know what their catchment areas and their traffic densities are. So there's a gap in our knowledge, and that's frustrating. But remember, at the bottom of that, all of those highway operators, if you like, the outfalls are causing pollution. So how does the tool work? So as I say, the Highways England Water Risk Assessment Tool was built on all the research that Leanne talked about earlier, and then it takes into account climatic conditions, traffic density, the catchment area drained, and the nature of the receiving watercourse, so that size and flow and energy in the receiving watercourse. And it's used by National Highways, Welsh Government, and lots of highway authorities, and they run the model and they say, does this outfall pose a risk of pollution to the receiving watercourse? And then if it says yes, then the tool will tell them roughly how much treatment to provide. And if it says no, there's no need to provide treatment. And as I say, at the moment, it looks as if National Highways have 18,000 discharges to watercourse, and 254 of those are identified by the tool as requiring the installation of treatment. And that just doesn't seem like enough. That image on the right, I'll show you a photographic evidence of Massey Brook. I'll show the data from Massey Brook in a minute, but that image on the right is the bottles that were taken of the discharge into Massey Brook, and I'll show you the results. But the point is that discharge contains polyaromatic hydrocarbons grossly in excess of the environmental quality standard. Now, if that was being made by you or if I operated an electroplating factory in Burnley, and you operated a paper manufacturing company in Barrow-in-Furness, and Leanne had a sausage skin making factory in Great Harwood, we would all have to have a permit to discharge for our industrial discharges into the river. So if we had industrial process waters that discharged to river, then they would have to have a permit to discharge, and that would strictly control the levels of pollution in that discharge, and particularly control any levels of priority hazardous substances and priority substances. And that bottle there would have to have permit conditions that controlled the level of polyaromatic hydrocarbons down to a level that it didn't cause a failure in the river. So if you and I have to have those permits, and the water companies have to have those permits for their wastewater treatment works, it doesn't make sense that the highway authorities don't have to have those permits for these discharges.
Jo, just to flag, you've got a few more minutes to wrap up, so we've got some questions.
All right, buddy. So because we know there's pollution in there, what we should be doing is sampling them, and sampling them when it rains. And then when we sample them, we work out how much pollution is in there, how much dilution we need, whether we've got enough dilution, and then you issue a permit that dictates how much pollution you can cope with, and therefore how much treatment you have to offer. So just look at some of the discharge results. This was Massey Brook, which is the one I've shown you the photograph. I've shown you the photograph of the discharge and the photograph of the bottle. The environmental quality standard maximum allowable concentrations are shown there in the 4th column, and then the results are in there in the 3rd column. And you'll see from the red boxes that most of the polyaromatic hydrocarbons fail the environmental quality standard. Now, they don't just fail a bit. One of those is over 700 times the environmental quality standard. So that little pipe would have to be diluted 700 times, theoretically, to achieve compliance downstream in the mixing zone. And so that's a problem in that little brook, and yet nobody's measuring it. And then this is Sidbrook, which is the other one I mentioned, which goes into a little pool upstream of an ornamental lake. And this one, again, you can see from column 3, the discharge fails the environmental quality standard for most of the polyaromatic hydrocarbons. And again, this one goes into standing water. So this one doesn't have anywhere, there's no opportunity for this to be aerated and dispersed. This goes into standing water. And so it's causing continued pollution. It's also causing pollution of a water body that wildfowl live on, which is another problem. And then this is the one, and you'll see in the report, if you read the whole report, that all the data for this outfall is there. This is a discharge in Cuerden Valley Park into the River Lostock from the M6. Now, the interesting thing about this slide is that if you look at the column on the right, the river is already polluted. The river is already failing the environmental quality standards upstream of the discharge. So there's something going on upstream that the Environment Agency need to investigate. But then the 2 discharges that were taken from the outfall, one a composite sample and one a spot sample, they both failed the environmental quality standards significantly. And so downstream of this outfall, the river fails. Downstream of the mixing zone, the river fails. Now, this isn't the only discharge off the motorway in this stretch of watercourse. There are 2 other discharges of motorway. There's also clearly something upstream of there because you've already got a failure in the river. But in this river catchment, which is the River Douglas catchment, there are 15 motorway outfalls going into that entire catchment, and none of them are monitored. And so the pollutant load is huge, and we're just not capturing that information. It's not in the River Basin Plan, it's not being captured, and there is no plan in place to do anything about it. So we took that data and we worked with Blackwell Water Consultancy, Dave Bryden, who did some modelling for us, because I was like, well, how does this look if you put it through the sort of modelling processes that the Environment Agency would put it through? And so Dave ran it through a modelling process. And although it's a very small data set, and the scientists amongst you will be wincing at the size of the data set, the model did suggest that there was that outfalls like that will have a detrimental effect on a typical regional river. And then Dave went on to carry out the risk assessment screening tests that you would have to carry out if you were applying for a permit. So we said, well, okay, what if the Environment Agency did say you have to apply for a permit? What would you do next? You would go through the screening tests. So Dave took the data through the screening tests, and it failed the 3 screening tests, which suggest again that it should be considered for permitting by the Environment Agency. So these levels of pollution that we're finding are levels of pollution that should be regulated. So it causes pollution. We know that the pollution to some extent causes harm to the aquatic ecosystem. We know that there's levels we're seeing exceed the published standards. We know that it's not been measured by anybody, frankly, and there are no permits in place. And yet the bottom bullet point's interesting. A discharge like that one into Massey Brook is a strict liability criminal offence. So if you or I were to make that discharge from our sausage skin factory or our paper factory or our electroplating factory, we could be prosecuted. And yet these discharges happen every day when it rains across the UK with no control at all. So what's to do? What can we do about it? I don't want to finish on a misery. There are treatment solutions. We can treat this stuff. If you can get most of the suspended solids out, you will take out most of the pollution, because the microplastic tire wear particles, the toxic metals, and the polyaromatic hydrocarbons are all squished up into the suspended solids. And so if you can capture most of the suspended solids, you will remove most of the pollution. For motorway runoff and trunk road runoff, the stuff we've just been looking at, I would always promote the use of a manufactured device at the top of the system. And that's not because I've got some weird fixation with manufactured devices, it's because they capture the pollution and isolate it from the environment. I don't want this stuff in the environment. I don't want it anywhere where creatures come into contact with it. I don't want birds to be drinking it. I don't want insects to be living in it. I don't want mammals to be eating it. I want it isolating from the environment. And so by putting a manufactured device in, that one there's a vortex separator, you can use an oil water separator, a sediment separator, you isolate the pollution from the environment and you take it away and you manage it. And you put one of those in and you empty it every year and you remove probably half of the sediment and perhaps a little bit more of the pollution. So put that at the top, design it well, make sure it's the right size, make sure it's maintained properly, and you've done half a job. You've done the best half of the job. Make sure you look after it and put a red ring around that to make me remember to say you've got to maintain these. That needs emptying every 12 or 18 months. If you don't empty it, it will stop working. And that's where the permit would come in, because the permit would dictate that it was emptied. And then we move on to vegetative devices. So we've taken out most of the pollution, we've isolated it from the environment, and then you can take that runoff from that manufactured device and put it into a pond, basin, wetland, swale, whatever. There are design criteria missing from the design guidance, though, and so some of the ponds that are being built, some of the devices that are being installed aren't big enough. The sediment yield isn't incorporated into the design calculations, so they're not even big enough to hold the sediment that's going to come off the catchment. And they're not necessarily put in the right order. So I see designs where the vortex separators put downstream of the pond, which makes no sense because we've got to take the sediment out upstream of the pond. So you have a manufactured device, you then have a vegetative device, and you design them properly with proper treatment flow rate, proper sediment yield calculations, and we need to update the guidance. And then you may even need tertiary treatment downstream of there. So you may need a funky new novel treatment device downstream of your pond to polish out some more pollution. This stuff needs treating before it goes into the water environment, and that's what we're doing. And then finally, how do we pay for it? Because this is going to cost billions, and everybody goes, oh, we haven't got billions of pounds. But the government have allowed the water companies to spend £56 billion on fixing the storm overflows, and we don't know if they're causing harm to the aquatic environment, or we don't know that they're all causing harm to the aquatic environment. So in that case, we should be able to find billions of pounds to fix this, because with good monitoring, we can see which ones are causing harm to the aquatic environment and we'll fix them. So we need to find a load of money. There are, I think, probably 4 ways to do this. One is a stormwater utility levy, which are used internationally, but there's no appetite for them in the UK at the moment, but they're a good idea because we'd all pay a bit alongside our council tax, and that would create a fund for managing stormwater. So it would retrofit SUDs, it would manage stormwater flooding, it would do rainwater harvesting, and it would do stormwater treatment devices for roads. So I'm a big fan of stormwater utility levies. If you can't do that, you can do product levies. So we pay an extra 10 quid for every tyre we buy, we pay an extra 3pence a litre on our fuel, and that creates a fund to pay for this work. That's another possibility. Road tax is another possibility, but nobody wants to put taxes up at the moment. And then there's a little tiny bit in your water bill that pays for the treatment and conveyance of surface water. And one of the options is to bump that up with the permission of Ofwat and then give that money to the highway authorities to do some of this work. So there are options. I have no idea how we make them work. So what do we do? The regulators need to do some monitoring. They need to issue permits. We need to measure that actual harm to aquatic life. And we need to do that, across the board. We need to properly reflect this pollution in our river basin plans. We need to update our design guidance because it's not up to date and it needs more stuff in it. And we desperately need maintenance schedules. And my final point is we need more research, and I love the research, but we mustn't wait for the research solutions. We must deliver solutions now while the research goes on. Let's do both at the same time. Thank you. I think I was probably even quicker than Leanne.
Thank you, Jo. That was a very good canter through the report. Excellent. Okay, we've got lots of questions coming in, so I'm going to dive into those as quickly as I can. So let's have a look. There was a question about where the report was. It should be on our website now, but we'll add a link to the chat so that you can find that. There was a question about sediment analysis and whether that would help identify problem areas. Leanne and Jo, I wonder whether you can say anything on that. I know there was a bit of research that was found into sediments, but not a massive amount.
You want to go first?
You want me to go? Sorry.
If you like, I can. I'm easy. You can go if you like.
Yes and no with these things. So we had a PhD student, for example, who was looking at for sediment hotspots in the River Lee sort of valley navigation channel, and we could sort of see a relationship between water quality, sediment quality in the smaller rivers, but in the bigger rivers, the sort of sediments move around so much that is a bit more complicated there. But yeah, definitely. I mean, so water gives you a snapshot. sediment can give you a sort of more historic time integrated sample, but there's lots of caveats around that. All right, so it's not an easy solution, but definitely need to look at the sediment as well, because there's dynamic relationship between the two of them.
Yeah, I read some research that suggested that the sediment, the sediment moves downstream depending on the nature of the river and takes the pollution with it. So you can see the effects of the pollution kilometers downstream of the discharge, because the pollution's kind of gone downstream with the sediment, and that's something we need to do more research on.
Great. And Jeff Jung said that this is all worrying. If councils can't even fix potholes, then how can they manage to fix this? But Joe, I think you did give some indications of where the funding might come from to help solve the problem with that
Yeah, and
levy.
there are examples of councils doing some really excellent retrofit suds work, which captures some of this road runoff, and they fund that through some really innovative. They get when someone's digging up the road to lay a gas main, they'll get them to put it back as suds rather than putting it back as it was before. That's brilliant, and I love those. There just comes a point when the road is too polluted, and you have to think quite hard about how to do that.
Yeah. There's a lot of questions here. There's a couple of questions about what happens to the pollutants if they're captured in those first stage treatment processes. Then what happens? Are they landfilled?
Well, yeah,
And
the hazardous.
make sure they don't end up going back into the environment.
Well, the hazardous waste, so they have to be treated. So they're treated at the waste handling facility. Unfortunately, yes, some of the residual waste after that treatment will be landfilled. But it's difficult, isn't it? I'd rather it went into a landfill than ended up in the river. And I'd rather it went in a landfill than ended up as sewage sludge and got spread to agricultural land and affected our vegetables. So it's a balance, isn't it? Where do you put it? And it is interesting because the more treatment we deliver, the more waste we create, and then we create another problem for ourselves. And I'm conscious of that, but it doesn't alter the fact that I want it out of the river.
If you think maybe like suds as like big sponges and soaking up everything, so you are concentrating the pollutants in one place, and the higher the concentration, we have the technologies that could remediate that sediment, but they're not sort of cost effective at the moment. But yeah, some studies show hazardous waste, some don't. It depends on the kind of the site and the lots of different sort of site specific factors.
Yeah.
But they are treatment systems, so the idea is to get it out of the wider environment and into a location where they can be managed.
Yeah. There's a couple of questions about permitting here. So from Tim, would permits be retroactive, or I suppose retrospective, or just for new road construction? And what would happen if permits were not granted?
Yeah, that's really interesting, because the solution would be, if you couldn't grant a permit, you would prohibit the discharge. That would be interesting. You just have to put a big bung up the pipe and then see which bit of the motorway flooded. That wouldn't go down very well. But they would, yes, you would apply the permits to existing outfalls. Definitely, that's exactly what we need to do. The permits wouldn't be backdated though. So the fee that you paid for your permit application on your permit maintenance would be from the day of the issue of the permit. You wouldn't be back charged 25 years. That would be a bit mean. I'm not sure anybody's got the money for that, but yeah, ideally these permits would be issued for existing outfalls on the existing road network that we find to be causing pollution. New outfalls, theoretically, will have treatment solutions constructed at the point of construction, and therefore the pollution should be less. That's a whole other story.
Yeah. Some questions about suds as well, which I think you sort of answered, Joe, but one question is about why not go straight to suds? Why use those first stage treatments? But I think you did talk about the need to ensure some of these contaminants don't go straight into the environment. Okay, and then there's a question. I've seen a couple of questions about CSOs and looking at sewer systems. If we look at things separately, says Melissa, Oh gosh, it's jumped, sorry. The questions jump around.
Yeah,
Anyway,
there was one as well. There's one from
asking whether, if you separated out road runoff and sewage, would that help or would that hinder?
Yeah, so Jackie as well. Jackie had asked a question about monitoring upstream and downstream of CSOs. Certainly, the work that the water companies are starting to do now, taking road runoff out of sewers to reduce storm overflow spills, is good, because it's better that water goes back into the water environment roughly where it falls, because that's good for the whole water cycle stuff. You will sometimes have to treat it before you can take it out of the sewer and put it in the river. Depends on the traffic density and the nature of the receiving watercourse. But it's certainly a good thing to do, is take surface water out of sewers. It's an excellent step forward. Regarding the monitoring that Jackie asked about, where the water companies are being required to monitor upstream and downstream of their storm overflows, I have a real problem with that, because it's a massive burden. It's a cost burden. It's a carbon burden, and I'm not entirely sure what it's going to tell us. I suspect it's going to tell us in a lot of situations that the river's more polluted upstream of the storm overflow than it is downstream. And then what do we do? So I think there's a risk. I think there's a risk associated with that work, because it will create more work. And also they're measuring, I think if I remember rightly, dissolved oxygen and ammonia, which tells you nothing about toxic pollution from highway runoff. So if the river is more polluted upstream of the storm overflow by toxic pollution, then that won't be picked up by that monitoring. And the river near me has a storm overflow that's little, and it goes into a tidal river. I don't really care. But there are 3 motorway discharges where there are 3 huge crossings from busy motorways, and they're not monitored at all. I'd sneak down with a screwdriver and nick the monitors off the CSO and go upstream and put them on the motorway outfall, because I'm much more interested in that pollution. So if you see me out and about with a screwdriver, you know you're in trouble.
And how about us as motorists? There was a question about, what can we do? Is there anything we can do as motorists to help solve this problem at source? And then there was another interesting question about, under the polluter pays principle, are the motorists the polluters, or is it those that manage the roads?
Car manufacturers. I think they would be if under extended producer responsibility. I think the car manufacturers would contribute. They're the ones who are making the profit from selling vehicles.
But you could take it back to the component parts, couldn't you? The bits that we know are causing pollution, so the tires and the brake components, and maybe the fuel and the lubricants and things. The actual body of the car probably wouldn't cause much pollution at all if you just sat it on the hard shoulder and let it get rained on. So perhaps
different countries have different attitudes. I do a lot of work in Sweden, and the big thing there is that you don't wash your car on the road, because they know that contributes pollution to the environment. They always wash it on a green space so that it'll filter through the soil, which is something I hadn't come across before I went to Sweden. But I think I don't have a short answer, so maybe I'll keep quiet.
And I think it'll be different if we ever privatise our national highways, which people talk about occasionally. If you privatise them and these were private companies operating roads for a profit, then all of a sudden it would be a different
that would be a different situation.
Yeah. Great. So I'm conscious where we are at time. There are still lots of questions there. And so I'm happy, and I think the panelists are happy to continue for another 10 minutes, to try and answer those. But I imagine some of you have got other things to go to. So I'll take this opportunity to say thank you very much for joining today. You can download the report from CIWEM's website and from Stormwater Shepherds website. And I hope this session has really helped elevate this issue in your minds, and you'll be able to go out to your colleagues and networks and really raise this up the agenda, because as we've said, it's rather an unmonitored and hidden issue. Okay, so we'll let those that need to go, and we'll spend another 10 minutes on these questions. Okay, so there were a couple about SUDS. So a few actually around SUDS, and I wanted to pick out those. How will these SUD systems be incorporated in design via national highways on new design and builds, and local authorities on maintenance frameworks, and water companies so correct treatment can be provided and maintained?
Crikey, there's a question. So the incorporation of SUDs into highway treatment schemes is well recognised. It happens all over the place. As I said earlier, we have to be really careful we're not creating habitats for wildlife that are just poisonous habitats. That's no good. So that it's important that the train has the relevant stages in it to deliver proper treatment. Certainly the highway authorities are quite good at some. There are some really good examples of highway authorities delivering multi-stage treatment train SUDs for new highways. So when they're building new roads, so there's two or three in Lancashire on the Heysham bypass and the Preston West Distributor Road, where they've got ponds, basins, wetlands, swales, some vortex separators, a mixture of treatment devices. Congleton, there's a new ring road around Congleton, which has got some really good solutions. They've even got closure devices at the bottom of the system, which is brilliant. So if there's a spillage, there's a closure device. So there are examples. It gets really complicated when you start to talk about, well, who owns and operates them. When you move into the realms of water companies, surface water sewers having SUDs, then the complexities start to kick in about who owns it, who operates it, who maintains it, who pays for it. But all that is to one side. The bottom line is you can deliver treatment solutions for these outfalls as long as you've got a bit of space.
Yeah, I absolutely agree, and there's lots of examples out there as well. But also just to say, almost the new roads are the easy bit. It's the retrofitting to existing systems. That's more of it. That's most of the roads, and that's a huge challenge.
Can I just? Somebody's put a comment in about looking at other trace chemicals and other emerging pollutants. I am conscious that there's a whole new world out there that I'm not really au fait with. So PFAS, PBDE, quinone. There are new chemicals that are being researched that are harmful that are included in urban runoff. I know UK WEA or QUEER are publishing a big paper on that at the moment, and I'm conscious of that. I'm just not au fait with it. I don't know whether you are a little bit more au fait than me, Leanne.
I'm not sure what the question was, but yeah, sorry.
It was just about the other chemicals that we hadn't mentioned. The
Yeah,
new
there's diversity. There's lots of studies out there, and then there's analytical development, and so because limits of detection are improving all the time, and then there's this question: just because you can detect it doesn't mean it has an effect. And then this whole world of non-target screening, where you're just basically screening samples to look for fragments, and then you can try and match those back to identify compounds that you weren't even looking. Because normally when you do chemical analysis, you just find what you look for, and so if you don't look for it, then you don't know it's there. But analytical approaches to address that. And then also the other important development is doing biological testing and chemical testing at the same time. So biological testing will tell you the effect, but not what's caused it. And chemical testing starts to tell you, identify the sources, and you need to know the source so you can manage it. So best practice is kind of to do the two things together. But that's quite difficult and complicated.
There's a couple of questions about fitting this stuff into very dense urban areas, and there isn't an easy answer. But one thing to remember is that if we can stop the stormwater getting onto the road surfaces in the first place, then we can reduce the problem. So I did a blog the other day about dealing with urban runoff in very dense city centres in London, and catching the roof runoff and catching the stormwater as it lands on the urban surface in a bloody big tank so we can use it for toilet flushing rather than letting it run onto the road. So that is one. There are examples around the world of roofing over roads to prevent this problem, which is quite an expensive solution. But you know,
just sort of putting it in a wider context. So cities need water. Urban areas are really good at generating water. We're all facing increasing water scarcity, even though it doesn't seem to ever stop raining. And so this is a resource. So how can we collect it, treat it, and store it so then we can use it? And we don't have to flush our toilets with, drinking water. So how can we view that as a resource, and then potentially a resource that the city can export to rural areas rather than kind of vice versa?
Absolutely. And if we can catch it before it becomes polluted, all the better.
Yes. I think we sorted that, Joe.
I fixed it. Matthew's asked about a working group. I would love to have a working group
Yes.
topic, Matthew. Let's see. Get into this. Drop us an email, and we'll see if we can set one up. I have tried in the past to have a roadshow, and I failed miserably. There is a round table at the moment looking at pollution from highway runoff, but it's a particular group of people who are running that to open up opportunities up to the supply chain. But round table would be cool. A working group, rather, would be cool.
And there was also a question about whether the proposals around funding and things have been put to the government agencies. And I suppose the answer is, well, this report is our first go at trying to do that, but we hope to have further discussions and further those the recommendations in the report off the back of this.
Yeah, and we did respond to the Environmental Audit Committee did a big inquiry into river pollution a couple of years ago, and we responded to that with these suggestions as well. And yeah, we respond to any consultation where we have the opportunity to say fix road runoff. We take that opportunity.
There's lots of questions that I feel we've touched on the answers to. Claire asks about the efficacy of wetland ponds, and whether have we got evidence for that, for removing highway pollutants?
Yeah, we've got, I think it was mentioned, so there are lots of studies that have looked at removal of a variety of pollutants within wetlands, within sort of treatment trains. And again, but I suppose the number of independent studies is kind of is a limiting factor. If you wanted to do a robust analysis, you'd tend say for each type of for retention ponds, for detention ponds, for wetlands, you'd maybe 10 independent studies, and that depth of data isn't there yet. It's coming. And then the other challenge when you're comparing across studies is difference in sampling methods. So there's about 1 million different ways you can sample rainfall. So I'm constantly writing proposals, looking to develop a standardized sampling methodology, but that hasn't been funded yet. So yeah, so there is data out there. There's data of systems that work really well. There's ones that haven't worked well. Some of them have dug down and work out why the systems aren't working, issues with design, a lack of maintenance. The evidence base is accruing all the time.
Glenn's asked about gully pots and emptying gully pots, and I really pleased that you've asked that, Glenn, because we have to remember all the time that pretty much all our roads in Britain are served with gully pots. And the concept is good. If they're maintained and cleaned often, they do capture a significant amount of suspended solids. And I think that we did some work recently in Chesham, I want to say Chesham, but somewhere like that, and concluded that actually the best thing to do was just road sweep more often and empty the gully pots more often, because there was no room to do retrofit suds and we needed to reduce the sediment pollution in the river. So absolutely, gully pots can be part of the solution, but they are very resource intensive to manage, and that's why highway authorities don't like it when I say let's empty them every 3 months. That's never a very popular solution, but it's a good idea.
Good. I think I'm going to have to close it there because of where I am, and I'm conscious it's 10 past already. We haven't managed to get through all the questions. Hopefully they're answered in the report, but if you find that they're not, then please do get in touch. So I think it just remains for me to say thanks very much to Joe and Leanne for your input today, and to Joe for also being a really great partner in writing the report, and obviously for collecting all of those samples and allowing us to have this evidence, which is great, and unveil it. So thanks very much. Thank you everyone for your time, and have a lovely rest of afternoon.